Hey everyone, welcome back. So in this video, we're going to be briefly talking about impulse. All right. So what is impulse? Well, impulse is a change in momentum. All right. I know you've probably seen or heard of conservation of momentum, and we're going to kind of touch on that difference. Like, oh, I thought momentum was conserved. Oh, it changes. Ah. Right. We'll talk about that a little bit. But for now, we're going to start with just the equation, kind of talk about how the equation works, all that good stuff. All right, so the equation for impulse, well, the symbol to start is the letter J, capital letter J. And we know that's a change in momentum. All right, well, we can set that equal to force times time. Right? So in other words, in order to change an object's momentum, you need a force for a certain amount of time. Right? If I don't apply force to my marker, I'm not going to change its momentum. If I let it go, gravity will be that force, and its momentum will change as long as gravity acts on it. Right? So there has to be a force on the object, and it has to be for a certain amount of time. Right? Now, we can look at this in a couple ways as well. Right? Think about your car for a second. Right? Let's say you're traveling down your road, wearing your seatbelt. You've got a newer car, so it's got a airbag in it, a bunch of airbags. Somehow you hit a deer or something, you get into an accident. Well, that car has all those safety devices to make sure that your momentum, when it changes, is for a long enough time that your force is going to be small enough that you're able to walk away. Right? So if you're moving in a car about 30 miles an hour, that's a pretty sizable momentum. Right? Then if you eventually come to a stop because of this collision, whatever it happens to be, well, then you're going to have that change be from what it was to zero. Now, if you make that force very large, right, that could be damaging to a person's body. Right? But if you can increase the time that that force is applied, you'll lower the force for that change, that same change in momentum, which means it's more likely that you'll walk away, right? The airbag is designed to slow you down over a longer period of time. The seatbelt is there to slow you down over a longer period of time, right? It's just there as safety precautions because of this general idea. You don't want that force to be too large if the goal is to be okay. All right, so that's just a one way to look at it. Now, when looking at impulse versus conservation of momentum, let's take a system where we have two carts, and those carts are going to collide. Okay, so it doesn't matter. Let's say this one's moving this way with a speed v, and this one is at rest. Okay, so eventually this one's going to collide. Well, if we take the system to be both carts, okay, when this cart collides with this cart, right, there's not going to be a change in momentum of the overall system because we're taking both things into account. The force that this one applies to this one is an internal force, right? It's all part of the system. We take the momentum of this one into account, take the momentum of this one into account, then the whole thing combined afterwards, right? But let's take just this cart as our system, just our cart at rest, right? Its momentum right now is zero. When this one hits it, it's going to start moving. Its momentum is no longer zero. Well, if this is just the system, this cart then becomes an outside force. By applying that outside force, you're able to change a momentum. Force times time equals a change in momentum. Right? So this object's momentum will change based on the product of the amount of force that this cart applies and how long that force is applied. Right? So that's kind of how we rectify these two differences. What is your system? Is your system the two objects? If so, you'll deal with conservation of momentum. Is your system just this object? Well, we calculate its change in speed based on delta P equals F times T. Right? So it's it all works, right? It might seem, oh, that's weird. I thought momentum was conserved. Well, yes, if we take all this as a system, that is true. But if we take just this thing as the system, going back to my deer car analogy, if you take the deer and the car as the system, total momentum will be conserved, right? But if you take just the car, right, the momentum is changing, right? And then we have to break it down. All right, well, you're inside the car, this, that, the other thing. So that part becomes a little complicated, but in a more macro sense, right, this is how you're able to calculate all this stuff. All right, so I hope that was helpful, and I'll see you next time.